Hello, and today I'm going to be talking about declarative programming in comparison to imperative programming. If you've been in the realm of computer science and programming over the last few years, you've probably heard the term declarative programming before. It's kind of a hot topic lately, with languages like Rust and Haskell becoming quite popular. And you might be wondering, well, what is it? And that's what I'm here to explain. So, what is declarative programming? Well, here's the definition that if you've ever tried to Google it, here's what you probably found. Imperative programming is how, and declarative programming is what. And this makes a lot of sense, but only after you understand it. Otherwise, it's not very helpful. So, I have a real world analogy that I think explains it pretty well. Let's say you want to get to a train station, so you call a cab, and you can tell the cab driver that you want to get to the train station, and you can do that in a couple of ways. The first way, we'll use the imperative way first, is you tell the cab driver, drive straight for half a mile, and then you tell him to turn right on Main Street, and then you tell him to drive straight for another 2 miles, and then tell him to drop you off at entrance 2. And that works. You just told the cab driver exactly how you wanted to get there with the exact instructions step by step. That is the imperative way. Or if we just take this back to the beginning, the declarative way of doing it would be to tell the cab driver to take you to the train station. And this is telling the cab driver what you want instead of how you want them to do it. So hopefully that makes it more clear. So now we can look at a couple of examples in code to hopefully solidify the understanding a little bit better and translate this into a more usable thing. So I have a couple of problems that I set up, and I've just written solutions in a couple of languages. So for the first one, given an integer vector of 32-bit integers, return an integer vector containing the doubled values of each. So the solution that you might be used to, the imperative solution, is something like this. This is Rust. So the Rust solution would just be you create a vector called answer, and then you loop over your input vector, and you push the doubled value of the input vector to the answer vector, and then you return that. And that's good. That works. But the declarative way of doing this would just be simply like this. So instead of looping over it, we use .iter, which turns the vector into a loop. Basically, it loops over the vector. And then you do .map, which takes each component of the vector, the current component, and we can change it to whatever we specify. So we can take number and we can multiply it by 2. And then after that, we just collect it back to a vector, and because Rust has implicit returns, this is all automatically returned. So as you can see, the declarative solution says what you want it to do. You want it to iterate over the numbers. You want to map each number to double the value of the number, and then you want to collect it. Compared to what we did above, which tells the computer how you want to loop over it and how you want to do everything. So next, I have a second problem. Given an array of people objects, return an array containing just the females. So I have set up a little Java program for this. There is a a person class that I created, but it only stores the gender of the person. So if we just look at this, as you can see, I've created an array list called females, and we're just looping over the array list and getting all of the ones that have a gender equal to female, and then returning that. Now, if we wanted to do this the declarative way, I have set up a declarative solution in Java. So we have the same thing, except this time we use stream, which is kind of the same thing as iter in Rust. And then we filter the person. Filter is a conditional, which means you can take each person in the stream, and you can just filter it for whatever you want, whatever condition you need to be true. And then anything that makes it through the filter can be collected to a list and returned. So it's the declarative way of doing that in Java. And then finally, for a final example, given a vector of strings, return a vector with just 5 words from the input that end with the letter M. So we have another Rust example here. This one's a little more complicated than the other ones. I tried to start easy and then work our way up. So we have our input, and then we have a result vector that I've created, and now we just loop over the input, and if it ends with M, and the result is less than or equal to 5, then we just push to result. And the declarative way of doing this looks like this. So we take words, go over it, we filter for words that end with just M, we use take to just get 5, and then we have to dereference each of the words because they get borrowed implicitly when you pass them into the iterator, and then we collect those words and it's automatically returned. So the declarative way in all of these is just a little more readable than the imperative way. So is writing it like this bad? Well, no, of course not. There's nothing wrong about writing the imperative solution. In fact, behind every declarative program, API, whatever, there is an imperative solution being run under the hood. Behind every .collect, there's a for loop that is collecting everything. Behind every filter, there's an if statement being run on the back end. But declarative programming abstracts that away so that you don't see it. All you see is .filter rather than a full if statement. So to sum this up, the imperative way of doing things is telling the computer how you want to do something, and declarative programming means telling the computer what you want to do, which essentially means that imperative programming caters more to the machine's model, whereas declarative programming will cater more to the model of a human brain, which is why declarative programming has become a lot more popular in recent years. And that's it. Now, hopefully, after this, you have a much better understanding of declarative programming and its comparison to imperative programming, why it may be better or worse in certain situations. I hope you enjoyed, and thank you.